Hello, dear teacher Rodrigo. We are Team DevUps. My name is Jorge Magne, and this is our Capstone Project progress presentation. Our project is, as you know, SIS, Crowdsourced Ideation Solution, a microservices platform that integrates a legacy system while adding new functionality. During this presentation, I will walk you through our work methodology, backlog structure, architectural and quality decisions, and we will conclude by explaining the functionality of our two APIs. We will be showing everything directly from our work environment in GitLab. We adopted an agile methodology based on Scrum. This allows us to be flexible and deliver value incrementally. Our process is defined by several key artifacts which we have documented in our wiki. Here we have our definition of ready and our definition of done. The definition of ready ensures that a user story is well defined before we start working on it, and the definition of done guarantees that every complemented piece of work meets our quality standards. We work with a prioritized backlog. These are some of the tasks we have worked on, moving them across our Kanban board as we progress through the sprint. This gives us clear visibility into the status of each task for all the team. To structure our backlog, we organize it into epics. Each epic represents a microservice. For example, the user management API for the legacy system and the SIS API for the new functionality. Our action plan or roadmap visualize how these epics are distributed over time and across sprints. It allows us to plan at a high level and communicate our goals. We used burn, burn down charts to track our progress. The solid line shows the story points we have burned each day compared to the ideal trend line. This allows us to see if we're on a schedule or if we need to adjust our plan. One of the most important decisions we made was about the architecture. To design it, we used the C4 model. Level 1 gives us the high level context. It perfectly reflects the legacy coexistence requirement, showing our SIS system and the other CLI operate on the same database. Level 2 breaks down the system into our two main containers, the users API in Java and the SIS API in .NET. This architecture, uh, a result of an initial spike or research, was a decision made to meet the scalability requirement, allowing each service to evolve independently. We also used use case diagrams to understand and validate the requirements from the user's perspective before designing the technical solution. To ensure product quality, we adopted several good practices. First, we defined a branching model based on Git flow. Every new feature is developed in its own branch and must be approved by another team member through a merge request before being integrated. This is our main rule for merging. As a documentation, we implemented two approaches. For the users API, we use code first approach, where the Swagger documentation is automatically generated from the Spring Boot code. In contrast, for the SIS API, we use a contract first approach, where the open API file is the source of truth and guides the implementation. Having interactive documentation for both APIs is a best practice that makes them much easier to use and test. Now, we will explain the key functionality of phase 1 and how our two products interact. The user's API built in Java is the entry point for users management. Its responsibilities are first to allow new user registration, and second to authenticate them through the auth login endpoint to generate a GWT security token. This service is the only one that handles password and user identity, fulfilling our security requirements. The SIS API, built in .NET, handles handles all the business logic, topics, ideas, and votes. By designing this API, it's stateless and does not manage users. All its endpoints are protected and require a valid JWT. The complete flow is as follows. A client first communicate with the user's API to get a token, then to use the feature of the sys API, like creating a topic, it must include that token in its request. Our sys API is configured to validate this token. This, the couplet design validates the completion of phase 1 and ensures a secure and scalable architecture. In summary, we have established a robust agile development process, resulting in two functional microservices built with different technologies but designed to work together. We have completed phase 1 and laid the foundation for the system expansion. Our work is guided by clear requirements and documented with modern practices. Thank you for watching, dear Rodrigo.